Welcome to the third episode of Full Beard Electronics. Today I fixed an issue with my Kolink Continuum 1200 watt power supply. I made an unboxing video featuring this power supply if you are interested. Overall it's a very nice power supply with one design drawback. It has a very high current surge when turned on via the main switch at the back. Simplified can be said that the power supply consists of a full bridge rectifier and large capacitors on the high voltage input side. So the failure happens because the main condensators behind the full bridge rectifier get initially charged up. This sometimes leads to popping the fuse. My estimation is that the fuse pops if the power supply is turned on when the AC voltage has a momentary value over a certain threshold, which leads to a high current surge. So I searched for ways to overcome this problem. My first idea was to use a choke coil simply connected in series with the phase line. In theory, this should block high frequencies because coils don't allow jumps in the current flow through them. And since turning on the power supply with the main switch can be seen as a high frequency jump, the coil should limit the initial current. The solution is very comfortable because the coil just can sit in a modified cable and you don't have to do anything in addition when turning on the power supply. I first wanted to simulate the circuit before I built it, so I used some data I found online, especially for the maximum surge current, which is 85 amperes, to design a simplified equivalent circuit of the high voltage input side of the power supply. The values of the main capacitors are combined 940 microfarad, and I estimated the series line resistance to be around 3.8 ohm. All simulations are designed that the voltage across the full bridge rectifier is turned on when the AC voltage reaches its peak. Now we come to the simulation of the solution with the coil. As you can see, the coil did not limit the peak current enough, only to around 45 amperes, and besides, in this model the additional coil produced a weird oscillation. So I decided that this circuit is of no use and I won't use it to correct the surge current. The second idea is the addition of a high power capable resistor in series to the phase line for startup. This solution is not quite as comfortable as the first one because the resistor cannot stay in the phase line during normal operation. So I added a second main power switch to bridge the resistor as soon as the condensators are charged up. As value for the resistor, I was limited to the resistors I had laying around. After some searching I found 3 100 ohm 5 watt ceramic resistors. I initially designed the circuit with one of them, which means a 100 ohm series resistance. The LT-SPI simulation showed that this solution has the desired effect. The current is limited to a maximum of 3.1 ampere. Due to the high capacitor values, the startup takes around 1 second. I estimate this to be a really good solution. Now to the practical side of this circuit. Somehow the 100 ohm series resistance was too high and the power supply detected the circuit as a bad power source and refused to turn on. So I added a second resistor parallel to the first one, leading to a series resistance of 50 ohm. This doesn't change the equivalent circuit simulation much, the peak current will approximately double to 6.2 ampere. This is still well within the 16 ampere limit of the circuit breaker. This modification did the trick and now I don't have to run after pop fuses anymore. Thank you for watching this video, maybe you have the same problem and can use my solution too.